Vale, esto es el empezar. Vale, pues preparar palomitas, gente, porque vamos a ver aquí en directo, para quien se pase, para quien no, a mí me interesa verlo. Así un vistazo por encima a la presentación. Yo iré pasando cosas porque obviamente no voy a estar viéndola toda, son 2 horas y quiero jugar al Zelda. Tengo muchas ganas de jugar. Entonces, no creo que me dure ni una hora, ¿vale? Vamos a ver un poco así por encima qué es lo que ha dicho Nvidia, porque parte de cosas, o sea, cosas que van a salir aquí seguramente puede que en un futuro, puede que no, pero algunas cosas puede que se añadan o que se implementen o que se utilicen en las gráficas dedicadas a videojuegos para ordenador, ¿vale? Como hemos visto en lo del ray tracing, primero pues iba a enfocarse solo a trabajo profesional, ¿vale? Y programas. Y ahora ya lo tenemos ya en videojuegos y todo, y cada vez más, y cada vez se ven mejor. Y ahora pues quieren implementar otra cosa que cuando se implemente, veremos a ver en qué tarjeta gráficas, pero cuando se implemente, que creo que lo comenté ya en un tweet, me parece que lo comenté en un tweet, si no recuerdo mal, hace unos días o hace una semana, me parece aproximadamente semana y media, de que Nvidia va a implementar una tecnología que lo que hará es que las gráficas utilicen menos VRAM, menos memoria dedicada de la propia GPU para llevar a cabo tareas. En el caso de estar ejecutando un videojuego, pues en tareas de polígonos, texturas y tal, va a utilizar los mismos núcleos, los tensor cores que llaman ellos, que se utilizan ya para el DLSS, pues van a utilizarse en paralelo también para esta nueva tecnología, se supone, para así ahorrar la utilización de la VRAM y así poder sacar todavía aún más rendimiento con menos hardware. Estamos, o sea, va a ser otra tecnología que va a aumentar la calidad visual porque aparte de mejorar la imagen nativa, porque la va a mejorar, ya lo hace el DLSS, al principio no, porque no estaba perfeccionado ni preparado ni a punto bien, pero lo mejoraron y ahora ya pues sí, hay juegos en los que en el DLSS se ve incluso mejor que en la nativa, aunque parezca una broma, pero sí que pasa. Está comprobado de hecho. Encima te da más rendimiento, pues esto lo que va a hacer es que seguramente nos aumenta aún más el rendimiento, pero sobre todo lo que va a hacer es hacer que lo que es en la parte del hardware, la parte técnica del hardware del componente que tengamos, en este caso la GPU, la tarjeta gráfica, esté consumiendo menos VRAM. Eso va a permitir, pues, poder utilizarla o poder tener una gráfica más barata, más asequible, con menos VRAM, pero que nos permita jugar sobre todo para resoluciones mayores. Si vosotros os habéis fijado, muchos os habéis fijado que cuando cambiamos las opciones gráficas en los juegos, pasamos, por ejemplo, de una resolución en calidades también, ¿vale? Se nota porque utiliza más VRAM, pero cuando pasamos de una resolución a otra en la misma calidad, en el mismo preset gráfico, lo que vemos es que aumenta el uso de la VRAM en las gráficas. Gráficas que a lo mejor con 8 gigas se quedan cortas, dan peor rendimiento al pasar de 1080p a 1440p, ¿vale? Pero encima la VRAM les limita aún más y aún dan un peor rendimiento del que podían dar por culpa de la VRAM. Pues esa tecnología, lo que Nvidia se supone que va a buscar es intentar solventar un poco ese tema. ¿Se va a solventar? Yo creo que al principio no, porque seguramente no sea perfecto. Va a pasar lo mismo que en el DLSS, pero luego a medida que vaya avanzando y se vaya perfeccionando, supongo que irá mejorando. No creo que lo saquen del todo, creo que pasará como tipo el del SS, o a lo mejor me equivoco y lo sacan directamente, que sería lo ideal, lo sacan directamente yendo full, yendo todo perfecto bien, haciendo que la GPU, lo que esté utilizando, lo que esté procesando, haga que utilice menos VRAM, memoria dedicada de la GPU, para llevar a cabo esa tarea y podamos abarcar más trabajo en el caso de programas o poder abarcar mejor rendimiento en el tema de juegos o mejor resolución, ¿vale? Poder dar un salto en resolución, pues a lo mejor una persona que dice, no, yo me quedo a jugar en 1080p porque no me quiero cambiar la gráfica, pues si esa tecnología, por ejemplo, llegara, que no lo creo, no lo creo, lo vamos a remarcar en grande, bien, no lo creo, porque esa tecnología seguramente va a pasar como el DLSS 3, va a ser solo exclusivo de la nueva generación de gráficas que sería la 5000, ¿vale? Ojalá que no, pero yo creo que sí, porque el tema es que ya no solo vale el que saquen gráficas con más rendimiento, que sí, ¿vale? Que sí, pero mucha gente, la mayoría, yo creo que no se cambia gráfica de un año a otro, ¿vale? Entonces lo que se va a buscar es ir sacando rendimiento de donde no lo hay, ¿vale? Ir rascando, como con el DLSS, para que sea un motivo para que la gente se vuelva a cambiar, porque vea un salto grande o importante, utilizando dichas tecnologías, pero eso está bastante difícil de conseguir, ¿vale? Eso está difícil. Y otra es que, claro, tenemos los precios caros de las gráficas, sumamente caros, no tiene ni sentido. Entonces, no, no conviene estar ahí malgastando tremendo pastizal de dinero. El que lo tenga, pues bueno, sí, se puede permitir, pues bueno, cada uno se gasta el dinero en lo que quiere, pero la gran mayoría, pues no podemos estar cambiando de gráfica año sí, año también. Entonces, esas tecnologías pues vendrían a ayudar un poco en ese aspecto, pero sobre todo irían a buscar pues el sacar más rendimiento donde todo hay. Vamos, o sea, veremos a ver cómo sale esa nueva tecnología. No sé si hablarán en esta presentación sobre eso, a lo mejor sí. NVIDIA ya utiliza una tecnología ¿cómo se llama? De escalado de texturas y de escalado de polígonos y todo eso, bueno, todo lo que carga la GPU para los videojuegos y tal, que me parece que salió pues sobre la serie 900, me parece, la Maxwell, ¿vale? Y siguen utilizando esa para hacer que no sea necesaria tanta VRAM en las GPUs. Si Nvidia no utilizara eso que ya está utilizando ahora mismo, esa técnica, esa tecnología, seguramente las gráficas necesitarían aún más VRAM de los modelos que tenemos ahora, de lo que tienen, ¿no? Los modelos que tenemos ahora en el mercado. Entonces, esto vendría a dar, pues, un pequeño, o quién sabe, a lo mejor es gran salto, o una ayuda en cuanto al uso de la VRAM. Y yo creo que falta hace porque están saliendo los juegos muy mal optimizados. Si siguen así, yo creo que al final nadie va a jugar a juegos nuevos porque la mayoría que salen, es que la mayoría que han salido últimamente están mal optimizados. Por parte de Sony, por parte de... Bueno, los que han salido en PC por parte de Sony. Los que han salido que no son de PC, por ejemplo, el de Gollum está fatal. Pero sobre todo, los mal porteados gastan una barbaridad de VRAM. De las GPU no tiene sentido. No sé lo que pasará, espero que eso mejore. Supongo que irán parcheando los juegos, ¿vale? Irán arreglando eso, pero bueno. Así que nada, comentando un poco todo el percal este, vamos a pasar a ver un poco la presentación. A mí me interesa, así que nada, vamos a verla. Sea bienvenido quien se pase por aquí a verla, me pueda hablar. De hecho, voy a poner aquí un uptime. Podemos aquí hablar sobre la presentación esta, a ver qué tal estás. Supongo que, bueno, saldrá Jensen Juan, el Juan de Nvidia, con su chaqueta de cuero aquí, como siempre hace, pues, comentando en qué están trabajando, como siempre, ¿no? Las tecnologías, lo que están avanzando en la inteligencia artificial y todo eso. Así que nada, a ver, espero que de volumen esté bien. Sin más esperas, vamos allá. Luego, lo dicho, continuaremos con el Zelda, ¿vale? Vamos allá. Espérate, de hecho, para que no esté ahí la gráfica, ¿vale? Para que no esté ahí la gráfica, vale, vamos allá. Está subtitulado, ¿vale? Para que lo podamos...
Transforming text into creative discovery. Turning movement into animation. An Infusing words with emotion.
台北是一个很棒的主办城市。
I am a healer. Exploring the building blocks that make us unique. Discovering new threats before they happen. And searching for the cures to keep them at bay.
Claro, es que la IA se va a implementar en todo, ¿vale? Se va a implementar en el campo de la medicina, todo. Es una barbaridad. Esto ya salió en otras presentaciones anteriores. Me parece que ya lo comentaron en 2 o 3 presentaciones. Todo esto. Anteriores. Si no recuerdo mal. En la astrología. Soy un navegador.
And the perfect setting for our most amazing stories. I am a creator. Adding new dimensions to creative expression. And reimagining our virtual selves. I am a helper.
Reinventarnos a nosotros mismos virtuales. Matrix está cada vez más cerca. Lo malo es que el día del juicio final también. Esperemos que no.
Harnessing the wisdom of a million programmers. And turning the real world into a virtual playground.
Bifrost AI. Bifrost.
Helped write the script.
Open AI. El chat GPT.
Breathe life into the words and compose the melody.
En la música también.
I am AI, brought to life by NVIDIA. Deep learning.
Que cobro vida gracias a NVIDIA, aprendizaje profundo, deep learning y mentes brillantes. I am AI. No se oyen los aplausos.
Please welcome NVIDIA founder and CEO Jensen Huang.
女士们、先生们，
Jensen
欢迎
Huang.
NVIDIA 创
Que el
办
Huang
人
se
暨
pronuncia
执行长黄仁勋先生。
Que viene.
We're back.
Estamos de vuelta. Cada vez tiene el pelo más blanco, ¿eh? Cada vez tiene
Live event
el ultra instinto más dominado.
4 years.
El ultra instinto de Goku.
Speech in 4 years. Wish me luck.
¿Qué ha dicho? ¿Qué ha dicho? Espera, no.
In almost 4 years.
Nuestro primer evento. Claro, es verdad. En vivo. Estamos de vuelta. Nuestro primer evento en vivo después de 4 años. Es verdad, por el COVID y todo eso.
Our first live event in almost 4 years. I haven't given a public speech in 4 years. Wish me luck. I have a lot to tell you, very little time, so let's get going. Ray tracing, simulating the characteristics of light and materials, is the
No voy a
ultimate
leerlo, ¿eh?
accelerated
Lo
computing.
podéis leer vosotros. Porque si no, menudo pateo, ¿eh? Yo iré viéndolo y quedándome y leyendo, claro.
We demonstrated for the very first time rendering this scene in less than few hours. After a decade of research, we were able to render this scene in seconds, 15 seconds on our highest end
15 segundos.
6 years ago. And then we invented NVIDIA RTX and combined 3 fundamental technologies: hardware accelerated ray tracing, artificial intelligence processing on NVIDIA Tensor Core GPUs, and brand new algorithms. Let's take a look at the difference in just 5 years. Roll it. This is running on CUDA GPUs 6 years ago, rendering this beautiful image that would have otherwise taken a couple of hours on a CPU. So this was a giant breakthrough already. Enormous speed up running on accelerated computing. And then we invented the RTX GPU. Run it, please.
Guau, cómo se ve, ¿eh?
The holy grail of computer graphics ray tracing is now possible in real time. This is the technology we have put into RTX, and this, after 5 years, is a very important time for us, because for the very first time, we took our 3rd generation Ada architecture RTX GPUs and brought it to the mainstream with 2 new products that are now completely in production. Are you? I got that backwards. Everything looks different, inside out and upside down. Okay, this is our brand new. Right here, you're looking at an Ada GPU running ray tracing and artificial intelligence at 60 frames a second. It's 14-inch. It weighs almost nothing. It's more powerful than the highest end PlayStation. And this is the RTX 4060 Ti for our core gamers. Both of these are now in production. Our partners here in Taiwan are producing both of these products in very, very large productions, and I'm really excited about them. Thank you very much.
La 4060 Ti, que bueno, hace poco se lanzó, de 8 gigas. A mí me parece que 8 gigas, por el precio que tiene, la patina un poco. Por el resto me parece bien, pero lo que tiene, la verdad. Pero porque de hecho es una bastante buena gráfica para 1440p ya incluso, aunque apunta más la 4070 al 1440p, pero la 4060 Ti, buah. Y encima siendo más barata. Pero habrá que esperar a la de 16 gigas sí o sí, porque 8 gigas yo veo que es muy poco para la potencia que tiene, o puede llegar a tener. Le hace bastante cuello de botella la VRAM a la gráfica, pero bueno. Ellos la han hecho de 8 gigas, vete tú a saber por qué. Siendo más rápida que la... Bueno, tampoco es mucho más rápida que la 3060 Ti, pero bueno. Lo que pasa es que tiene DLSS 3. Y DLSS 3 es la leche. Es una puta barbaridad el DLSS 3. El DLSS 3 básicamente lo que hace es... por ejemplo, con la 4060 Ti he visto que llega a dar los mismos FPS que una 3090 Ti. Es espectacular. O sea, es espectacular. Entonces, visto así, estás pagando menos por mucho más rendimiento que antes. Pero claro, solo en juegos que tienen DLSS 3. Todos los juegos no lo tienen. Que esa es la putada. Ni en todos los juegos vale la pena activarlo. Que esa es la otra putada. O directamente no lo tienen. Lo que he dicho antes. Eso también es una barbaridad. Lo del NVIDIA Ace, que lo vimos ya también me parece que lo mostraron un poco en otras presentaciones. Lo vimos también por encima, pero increíble.
Has a great back end, has a Tensor RT. Tensor RT is NVIDIA's deep learning optimizing compiler, and you could deploy it on NVIDIA GPUs as well as output Onyx and industry standard backend so that you can run it on any device. Let's take a look at this scene in just a second, but let me first tell you about it. It is completely rendered with ray tracing. Notice the beautiful lights. So many different lights, and all of the different lights are projecting light from that source. So you have all kinds of direct lights. You have global illumination. You're going to see incredibly beautiful shadows and physics simulation. And notice the character, the beautiful rendering of the character. Everything is done in Unreal Engine 5. We partnered with a avatar framework, an avatar tool maker called AI. And together, we developed this demo you're about to see. Okay, run it, please. Everything is real time.
Hey,
Guau,
Jen.
cómo se ve, ¿no?
Unfortunately, not so good.
Ah, y le habla y todo.
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful,
Buah,
guy.
parece que sea la vida misma. Muy real, ¿eh? Y es un juego.
None of that conversation was scripted.
¿Cómo se ve, no?
That
Y los gestos, la cara.
AI character, a backstory. His story about his ramen shop and the story of this game. And all you have to do is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for all kinds of characters to be generated. They're all domain, they have their own domain knowledge. You can customize it, so everybody's game's different. And look how wonderfully beautiful they are and natural they are. This is the future of video games. Not only will AI contribute to the rendering and the synthesis of the environment, AI will also animate the characters. AI will be a very big part of the future of video games. The most important computer of our generation is unquestionably the IBM System 360. This computer revolutionized several things. The first computer in history to introduce the concept of a central processing unit, the CPU, virtual memory, expandable I/O, multitasking, the ability to scale this computer for different applications across different computing ranges. And one of the most important contributions and one of its greatest insights is the importance of preserving software investment. The software ran across the entire range of computers, and it ran across multiple generations. So that the software you develop, IBM recognized the importance of software, recognized the importance of preserving your investment, and very importantly, recognized the importance of installed base. This computer revolutionized not only computing, and many of us grew up reading the manuals of this computer to understand how computer architecture worked, to even learn about DMA for the very first time. This computer not only revolutionized computing, it revolutionized the thinking of the computer industry. System 360 and the programming model of System 360 has largely retained until today. 60 years. In 60 years, $1 trillion worth of the world's data center all basically used the computing model that was innovated all the way 60 years ago until now. There are two fundamental transitions happening in the computer industry today. All of you are deep within it and you feel it. There are two fundamental trends. The first trend is because CPU scaling has ended. The ability to get 10 times more performance every 5 years has ended. The ability to get 10 times more performance every 5 years at the same cost is the reason why computers are so fast today. The ability to sustain 10 times more computing every 5 years without increase in power is the reason why the world's data center hasn't consumed so much more power on Earth. That trend has ended, and we need a new computing approach, and accelerated computing is the path forward. It happened at exactly the time when a new way of doing software was discovered, deep learning. These two events came together and is driving computing today. Accelerated computing and generative AI. This way of doing software, this way of doing computation, is a reinvention from the ground up, and it's not easy. Accelerated computing is a full stack problem. It's not as easy as general purpose computing. The CPU.
Que claro, para explicarlo todo, voy a detenerme aquí porque, a ver, para explicarlo todo, todo lo que ellos están, siempre en las presentaciones han hecho más o menos lo mismo, o parecido. Para estar explicando o llegar al punto de lo que están haciendo, de explicar lo que ellos están haciendo, hay que decir todo lo que, bueno, del origen. Casi prácticamente muchas cosas hay que ir al origen, dónde es la base, cómo empezó todo, cómo han llegado hasta aquí, por qué han sacado eso. Necesidad, ¿no? Pero claro, hay que desembuchar, o sea, hay que explicar, hay que desembuchar, sí, creo que es la palabra perfecta, ¿no? Todo lo que ha habido hasta ese momento en el que ellos han logrado lo que han logrado, ¿vale? No, no solo ellos, no solo ellos, pero ellos lo que están tratando de hacer es estar sacando tecnologías para, pues, mejorar, ¿no? Mejorarlo todo mediante la inteligencia artificial, básicamente.
High-level programming languages,
A
great
ver.
compilers. Almost anybody could write reasonably good programs because the CPU is so flexible. However,
Si lo
its
pongo en
ability to
grande,
continue to
¿cómo se
scale
ve?
and performance has ended.
Ah, se ve bien
We
así
need a new
también.
approach.
Y si hago
Accelerated
así,
computing is full stack. You have to re-engineer
vamos a
everything
poner
from
así.
the top down and from the bottom up, from the chip to the system software,
Más
new
grande.
algorithms, and of course, optimizing the applications. The second is that it's a data center scale problem. And the reason why it's a data center scale problem is today, the data center is the computer. Unlike the past when your PC was a computer or the phone was a computer, today your data center is the computer. The application runs across the entire data center. And therefore, it's vital that you have to understand how to optimize the chips, the compute, the software across the NIC, the switch, all the way to the other end in a distributed computing way. And the third, accelerated computing is multi-domain. It's domain specific. The algorithms and the software stacks that you create for computational biology and the software stack you create for computational fluid dynamics are fundamentally different. Each one of these domains of science need their own stack, which is the reason why accelerated computing has taken us nearly 3 decades to accomplish. This entire stack has taken us nearly 3 decades.
3 décadas
However,
les ha llevado.
performance is incredible now.
Buah.
After 3 decades, we realize now that we're at the tipping point. A new computing model is extremely hard to come by. And the reason for that is this. In order for there to be a new computing model, you need developers. But a developer would only come if developers have to create applications that end users would buy. And without end users, there would be no customers, no computer companies to build computers. Without computer companies like yourself building computers, there would be no install base. Without install base, there would be no developers. Without developers, there'll be no applications. This loop has been suffered by so many computing companies in the 40 years that I've been in this industry. This is really one of the first major times in history a new computing model has been developed and created. We now have 4 million developers, 3,000 plus applications, 40 million CUDA downloads in history, 25 million just last year. 40 million downloaded in history, 25 million just last year. 15,000 startup companies in the world built on
Wow.
NVIDIA today, building on NVIDIA today, and 40,000 large companies, enterprises around the world.
40.000 grandes empresas.
We have now reached the tipping point of a new computer.
Claro, es que esto es el futuro. O sea,
This new
es
computer
igual que
is now
yo cuando hice el vídeo del DLSS,
embraced by just about
cuando
every
salió,
company.
que me parece que era con el juego de Control,
There's a reason for that.
en el apartado de los
Turns out that
videojuegos,
every
el DLSS,
single computing approach
en ese momento, que había hace poco había salido,
analysis is
estaba claro que iba a ser el futuro.
the PC
Porque
revolution that started
ya sin estar del todo bien implementado o funcionando correctamente, no estaba bien optimizado, ni sacado en los juegos, ni nada, ni perfeccionado,
in the 80s
ya el rendimiento que te daba de más
PC revolution.
era brutal, era el rendimiento de gratis que tenías de más con la GPU, que
Mobile devices was
multiplicaba mucho más el rendimiento, esa tecnología, que, por ejemplo, pasar de una gráfica de una generación a otra del mismo modelo, por ejemplo. Da igual el salto que dieran,
integrated into one.
el DLSS lo superaba.
As a result,
Por eso era una tecnología que, bueno, al principio no caló demasiado, pero cuando ya se perfeccionó del todo sí que se ha visto aún más el potencial. Porque va por hardware, con un buen software. Y ahí está el truco. Si haces un buen software para el hardware que tienes y le sacas provecho, pues es lo que pasa, ¿no? A ver, un momento. ¿Ha dicho? Todos estamos integrados en uno. Y como resultado, no solo puedes disfrutar mejor de su vida, sino que también ahorra mucho dinero, claro. Porque solo con tener un dispositivo que lo tenga todo, ya estaría.
Accelerated computing used for large language models. For large language models, basically the core of generative AI. This example is a $10 million server, and we costed everything. We costed the processor, we costed all the chips, we costed all the network, we costed literally everything. And so $10 million gets you nearly 1,000 CPU servers, and to train, to process this large language model takes 11
Toma 11 gigavatios hora.
Okay, this is what happens when you accelerate this workload with accelerated computing.
Y esto es lo que, a ver.
And so with $10 million, for a $10 million server, you buy 48 GPU servers. It's the reason why people say that GPU servers are so expensive. Remember, people say GPU servers are so expensive. However, the GPU server is no longer the computer. The computer is the data center. Your goal is to build the most cost-effective data center, not build the most cost-effective server. Back in the old days when the computer was the server, that would be a reasonable thing to do. But today, the computer is the data center. And so what you want to do is you want to create the
La
most
computadora es el
data
centro de
center,
datos.
best TCO. So for $10 million, you buy 48 GPU servers. It only consumes 3.2 gigawatt hours
3,2.
and
Mucho menos,
4
¿eh?
times the performance. Let me just show it to you one more time. This is before, and this is after, and this is...
Y encima ocupa mucho menos espacio. Que parece una tontería, pero mucho menos calor generado.
And so,
Consume muchísimo menos.
let me show you something else. Okay, so this is $10 million again, 960 CPU servers. Now this time we're going to be ISO power. We're going to keep this number the same. We're going to keep this number the same. Okay? So this number is the same amount of power. This means your data center is power limited. In fact, most data centers today are power limited. And so with being power limited, using accelerated computing, you can get 150 times more performance with 3 times more cost. But why is that such a great deal? The reason for that is because it's very expensive and time-consuming to find another data center. Almost everybody is power limited today. Almost everybody is scrambling to break new ground to get more data centers. And so if you are power limited, or if your customers are power limited, then what they can do is invest more into that data center, which has 11 gigawatts, and you can get a lot more throughput. Continue to drive your growth. Here's another example. This is my favorite. If your goal is to get the work done, you don't care how. Your goal is to get the work done, you don't care how. And this is the work you want to get done. ISO work. Okay? This is ISO work. All right, look at this.
Hostia.
Oh, 先做嘴急。Taiwanese people love that, right? Nice to see you, Carol. Nice to see you, Spencer. Okay, so let's do that one more time. It's so delightful. Look at this. Oh, no. Okay, look at this. Look at this. Before, after. The more you buy, the more you save. That's right. The more you buy, the more you save. The more you buy, the more you save. That's NVIDIA. You don't have to understand the strategy. You don't have to understand the technology. The more you buy, the more you save. That's the only thing you have to understand. Data center. Now, why is it? You've heard me talk about this for so many years. In fact, every single time you saw me, I've been talking to you about accelerated computing. I've been talking about accelerated computing, well, for a long time, well over 2 decades. And now, why is it that finally it's the tipping point? Because the data center equation is very complicated. This equation is very complicated. This is the cost of building a data center. The data center TCO is a function of, and this is the part where everybody mess up. It's a function of the chips, of course, no question. It's a function of the systems, of course, no question. But it's also, because there's so many different use cases, it's a function of the diversity of systems that can be created. It is the reason why Taiwan is at the bedrock, at the foundation of the computer industry. Without Taiwan, why would there be so many different configurations of computers? Big, small, powerful, cheap, enterprise, hyperscale, supercomputing. So many different types of configurations. 1U, 2U, 4U, right? And all completely compatible. The ability for the hardware ecosystem of Taiwan to have created so many different versions that are software compatible, incredible. The throughput of the computer, of course, is very important. It depends on the chip. But it also depends, as you know, the algorithm, because without the algorithm libraries, accelerated computing does nothing. It just sits there. And so you need the algorithm software libraries. It's a data center scale problem, so networking matters. If networking matters, distributed computing is all about software. Again, system software matters. And before long, in order for you to present your system to your customers, you have to ultimately have a lot of applications that run on top of it. The software ecosystem matter. Well, the utilization of a data center is one of the most important criteria of its TCO. Just like a hotel. If the hotel is wonderful, but it's mostly empty, the cost is incredible. And so you need the utilization to be high. In order for the utilization to be high, you have to have many different applications. So the richness of the applications matter. Again, the algorithm and libraries, and now the software ecosystem. You purchase a computer, but these computers are incredibly hard to deploy. From the moment that you buy the computer to the time that you put that computer to work to start making money, that difference can be weeks, if you're very good at it, incredibly good at it. We can stand up a supercomputer in a matter of a couple of weeks because we build so many all around the world, hundreds around the world. But if you're not very good at it, it could take a year That difference, depriving yourself the year of making money and the year of depreciation, incredible cost. Life cycle optimization. Because the data center is software defined, there are so many engineers that will continue to refine and continue to optimize the software stack. Because NVIDIA's software stack is architecturally compatible across all of our generations, across all of our GPUs, every time we optimize something, it benefits everybody. Every time we optimize something, it benefits everybody. So life cycle optimization, and of course, finally, the energy that you use, power. But this equation is incredibly complicated. Well, because we have now addressed so many different domains of science, so many industries, and in data processing, in deep learning, classical machine learning, so many different ways for us to deploy software, from the cloud to enterprise to supercomputing to the edge, so many different configurations of GPUs, from our HGX versions to our Omniverse versions to our cloud GPU and graphics versions, so many different versions. Now the utilization is incredibly high. The utilization of NVIDIA GPU is so high, almost every single cloud is overextended. Almost every single data center is overextended. There are so many different applications using it. So we have now reached the tipping point of accelerated computing. We have now reached the tipping point of generative AI. And I want to thank all of you for your support and all of your assistance and partnership in making this dream happen. Thank you. Every single time we announced a new product, the demand for every single generation increased and increased and increased. And then, one generation, it hockey steps. We stick with it, we stick with it, we stick with it. Kepler, and then Volta, and then Pascal, and then Volta, and then Ampere, and now this generation of accelerated computing, the demand is literally from every corner of the world. And we are so excited to be in full volume production of the H100. I want to thank all of you for your support. This is incredible. H100 is in full production, manufactured by companies all over Taiwan, used in clouds everywhere, enterprises everywhere. And let's take a look at a short video of how H100 is produced.
Aquí van a enseñar cómo lo producen, ¿no? Cómo lo hacen. Lo producen allí en Taiwán. Supongo que será un vídeo a cámara rápida. Bueno, a lo mejor va así de rápido, Pero sí que tiene la pinta, de ir así de rápido.
It's incredible. This computer,
Y lo pequeño que es comparado, bueno, a lo de hace años. Y la potencia que tiene.
8 Hopper GPUs. Let me show it to you.
35.000 componentes.
All right, this I would lift this, but I still have the rest of the keynote I would like to give. This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect. This computer is $200,000. And as you know, it replaces
Cuesta $200.000.
So this, I know it's a very, very expensive computer. It's the world's single most expensive computer that you can say The more you buy, the more you save. This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100 with the world's first computer that has a transformer engine in it. The performance is utterly incredible. Hopper's in full production. We've been driving computing, this new form of computing, for 12 years. When we first met the deep learning researchers, we were fortunate to realize that not only was deep learning going to be a fantastic algorithm for many applications, initially computer vision and speech, but it would also be a whole new way of doing software. This fundamental new way of doing software that can use data to develop, to train a universal function approximator of incredible dimensionality. It can basically predict almost anything that you have data for, so long as the data has structure that it can learn from. And so we realized the importance of this new method of developing software, and that it has the potential of completely reinventing computing. And we were right. 12 years later, we have reinvented literally everything. We reinvented, of course, we started by creating a new type of library. It's essentially like a sequel, except for deep learning, for neural network processing. It's like a rendering engine, a solver for neural network processing called cuDNN. We reinvented the GPU. People thought that GPUs would just be GPUs. They were completely wrong. We dedicated ourselves to reinventing the GPU so that it's incredibly good at tensor processing. We created a new type of packaging called SXM and worked with TSMC on CoWoS so that we could stack multiple chips on the same die. NVLink so that we can connect these SXM modules together with high-speed chip-to-chip interconnect. Almost a decade ago, we built the world's first chip-to-chip SerDes so that we can expand the memory size of GPUs using SXMs and NVLink. And we created a new type of motherboard we call it HGX that I just showed you. No computers has ever been this heavy before or consumed this much current. Every aspect of a data center had to be reinvented. We also invented a new type of computer appliance so that we could develop software on it, so that third-party developers could develop software on it with a simple appliance we call DGX. Basically, a giant GPU computer, DGX. We also purchased Mellanox, which is one of the great strategic decisions of our company, because we realized that in the future, if the data center is the computer, then the networking is the nervous system.
Si el centro de datos es la computadora... A ver.
It had to be reinvented. We also invented
También inventamos un nuevo tipo de dispositivo informático que, para que pudiera desarrollar software en él.
a new type of
¿Para
computer
qué?
appliance so that we could develop software on it, so that third-party developers could develop
Tercero, los
software on
desarrolladores
it.
pueden desarrollar software en él con un dispositivo simple que llamamos DGX básicamente.
Basically, a giant GPU
Una computadora gigante, también compramos Mellanox.
computer.
Vale, ahora viene la clave. Esto ya creo que lo comentó en el otro, en la nota Keynote, creo. O cuando compraron a Mellanox. Decisiones estratégicas de nuestra empresa, porque nos dimos cuenta de que en el futuro, si el centro de datos, que es lo que ha estado hablando hasta ahora, el centro de datos es la computadora, entonces la red es el sistema nervioso si el centro de datos se va a configurar. Es la computadora, entonces. Claro, la red pasa a ser, sería como la computadora a la vez, ¿no? Todo junto. La red define el centro de datos, que fue una adquisición increíblemente buena, y desde entonces hemos hecho muchas cosas juntos. Y voy a mostrarles algunas realmente Algún trabajo realmente increíble hoy. A ver.
And then, of course, an operating system, if you have a nervous system, a distributed computer, it needs to have an operating system. And the operating system of this distributed computing we call Magnum I/O, some of our most important work. And then all of the algorithms and engines that sit on top of these computers, we call NVIDIA AI. The only AI operating system in the world that takes data processing, from data processing to training, to optimization, to deployment and inference. End-to-end deep learning processing. It is the engine of AI today. Well, every single generation since Kepler, which is K80, to Pascal, Volta, Ampere, Hopper, every 2 years, we took a giant leap forward. But we realized we needed more than even that, and which is the reason why we connected GPUs to other GPUs called NVLink, build one giant GPU, and we connected those GPUs together using InfiniBand into larger scale computers. That ability for us to drive the processor and extend the scale of computing made it possible for the AI research organization, the community, to advance AI at an incredible rate. We just kept pushing and pushing and pushing. Hopper went into production August of last year, August 2022. 2024, which is next year, we'll have Hopper next. Last year, we had Quantum. 2 years from now, or next year, we'll have Quantum next. So every 2 years, we take giant leaps forward, and I'm expecting the next leap to be giant as well. This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. These AI supercomputers are a new type of factory. It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company.
Esto no se ha traducido, lo que está diciendo ahora.
This
Ahora.
translates to your throughput. This translates to your scale. And you will build it in a way that is very, very good TCO. Well,
Vamos a adelantarlo ya. Hemos visto bastante, ¿eh? Llevamos bastante rato. Vamos a ir resumiéndolo un poco.
Use unsupervised learning from another source of information that we call prompts. We can now guide the AI to generate information of all kinds. We can generate text to text, text to image. But the important thing is this: information transformed to other information is now possible. Text to proteins, text to chemicals, images to 3D, images to 2D, images to text captioning, video to video. So many different types of information can now be transformed. For the very first time in history, we have a software technology that is able to understand the representation of information of many modalities. We can now apply computer science. We can now music.
Vale, vamos a ver.
Enjoy it right here in Taiwan. It's best from the night market.
The only input was words. The output was that video. Okay, here's another prompt.
A ver.
Tofu is. You can enjoy it right here in Taiwan. It's best from the night market. I was just there the other night.
A ver.
Okay, play it.
Hi, Computex. I'm here to tell you about how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market.
The only input was words. The output was that video. Okay, here's another prompt. Taiwanese, we tell this AI, okay, this is a Google text-to-music. Traditional Taiwanese music, peaceful, like it's warm and raining in a lush forest at daybreak. please. Okay. We send text in. AI says, okay, this music. Okay, here, this one. I am here at Computex. I will make you like me best. Sing it with me. I really like NVIDIA. Okay, so this is the word. These are the words. These are the words. And hey, voice mod, could you write me a song? These are the words. Okay, play it.
I am here at Computex. I will make you like me best. Yeah, sing it with me. I really like NVIDIA.
Hostia, ¿no? ¡Qué fuerte, tío! Ha hecho una canción con el texto.
Okay, so obviously this is a very
Bueno, algo así había visto, pero no tan bueno.
Many generative AI startups. We're working with some 1,600 generative AI. They're in all kinds of
No,
domains,
nada
domains,
parecido.
media,
O sea, muy...
biology. This is one of the most important areas.
Generador de canciones muy malos.
Digital biology is
Hostia, cómo lo ha hecho de bien.
This is going to be an incredible thing. Just as we had Synopsis and Cadence help us create tools so that we can build wonderful chips and systems, for the very first time, we're going to have computer-aided drug discovery tools. And they'll be able to manipulate and work with proteins and chemicals and understands disease targets and try all kinds of chemicals that previously had never been thought of before. Okay, so really, really important area. Lots of startups, tools, and platform companies. And let me show you a video of some of the work that they're doing. Play it, please.
Generative AI is the most important computing platform of our generation. Everyone from first movers to Fortune 500 companies are creating new applications to capitalize on generative AI's ability to automate and co-create. For creatives, there's a brand new set of tools that would be simply impossible a few years ago. Adobe is integrating Firefly with their creative apps, ethically trained and artist-friendly. You can now create images with a simple text prompt.
Te genera la imagen automáticamente. Te la cambia a lo que escribes. Escribes lo que quiere que aparezca y te lo pone.
Microsoft has created a co-pilot for Office apps. Every profession is about to change. Tab 9 is democratizing programming by tapping into the knowledge base of 1 million developers to accelerate application development and reduce debugging time. If you're an architect or just thinking of remodeling your home, Planner 5D.
Vale, vamos a pasarlo un poco. Casi 200.000 millones de transistores. ¿Cómo no va a valer caro eso? Casi 200.000 millones de transistores ahí.
Look at this. This is Grace Hopper.
Grace Hopper.
This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. And so the GPU can reference the memory, the CPU can reference the memory, and any unnecessary copying back and forth could be avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer is on here. All of the uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. Incredible levels of performance. This took us several years to build, and I'm so excited about it. And I'll show you some of the things that we're going to do with it. Janine, thank you. 谢谢. You're supposed to say naughty. Mike. 不要客气. Okay, so 4 petaflops transformer engine, 72 CPU cores. They're connected together by a high-speed chip-to-chip link, 900 gigabytes per second. And so the local memory, 96 gigabytes of HBM3 memory, is augmented by LPDDR memory across this link, across a very, very large and high-speed cache. So this computer is like none other the world's ever seen. Now, let me show you some of its performance. So I'm comparing here on 3 different applications. And this is a very important application. If you've never heard of it, be sure to look into it. It's called vector database. Vector database is a database
Base de datos
that has
vectorial.
tokenized, that has vectorized the data that you're trying to store. And so it understands the relationships of all of the data inside its storage. This is incredibly important for knowledge augmentation of the large language models to avoid hallucination. The second is deep learning recommender systems. This is how we get news and music and all the text that you see on your devices. Recommend, of course, music and goods and all kinds of things. Recommender system is the engine of the digital economy. This is probably the single most valuable piece of software that any of the companies in the world runs. This is the world's first AI factory. There will be other AI factories in the future, but this is really the first one. And the last one is large language model inference. 65 gigabytes. 65 gigabytes is a 65 billion parameters is a fairly large language model. And you can see that on a CPU it's just not possible. The CPU is simply not possible. With Grace Hopper, with Hopper on an x86, it's faster, but notice it's memory limited. You could, of course, take this 400 gigabytes and cut it up into a whole bunch of small pieces, shard it, and distribute it across more GPUs, But in the case of Grace Hopper, Janine, 再给我一次. Oh, Janine doesn't speak Chinese. 不要紧，拍谁? Okay. Grace Hopper has more memory on this one module than all of these. Does that make sense? And so as a result, you don't have to break the data into so many pieces. Of course, the amount of computation of this is higher, but this is so much easier to use. And if you want to scale out large language models, if you want to scale out vector databases, if you want to scale out deep learning recommender systems, this is the way to do it. This is so easy to use. Plug this into your data center, and you can scale out AI. Okay? So this is the reason why we built Grace Hopper. The other application that I'm super excited about is the foundation of our own company. NVIDIA is a big customer of Cadence. We use all of their tools. And all of their tools run on CPUs. And the reason why they run on CPUs is because NVIDIA's data sets are very large. And the algorithms are refined over very long periods of time. And so most of the algorithms are very CPU-centric. We've been accelerating some of these algorithms with Cadence for some time, but now with Grace Hopper, and we've only been working on it for a couple of days and weeks, the performance speed up, I can't wait to show it to you, is insane. This is going to revolutionize an entire industry, one of the highest compute-intensive industries in the world, of course, designing chips, designing electronic systems, CAE, CAD, EDA, and of course, digital biology. All of these markets, all of these industries require very large amounts of computation, but the data set is also very large, ideal for Grace Hopper. Well, 600 gigabytes is a lot. 600 gigabytes is a lot. This is basically a supercomputer I'm holding in my hands. This 600 gigabytes is a lot. But when you think about it, when we went from LXNet of 62 million parameters 12 years ago and trained on 1.2 million images, it is now 5,000 times bigger with Google's Palm. 5,000 times bigger with 340 billion parameters. And of course, we're going to make even bigger ones than that. And that's been trained on 3 million times more data.
3 millones de veces más datos.
So literally in the course of 10 years,
Buah.
the computing problem of deep learning.
El problema informático del aprendizaje profundo aumentó 5.000 veces para el software
Increased by 5,000 times for the software and 3
y 3 millones de veces para el conjunto de datos. Ninguna otra área de la informática ha aumentado tan rápido.
million times for the data set. Grace Hopper at 900 gigabytes per second. 600 gigabytes, 900 megabytes
900 gigabytes por
per
segundo.
second. 8 of them connected together as a pod, and then we connect 32 of them together with another layer of switches. And in order to build this, 256 Grace Hopper super chips connected into 1 exaflops. 1 exaflops. You know that countries and nations have been working on exaflops computing and just recently achieved it. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every
Wow.
GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected. Why don't we take a look at what it really looks like? Play, please. This is 150 miles of cables, fiber optic cables, 2,000 fans, 70,000 cubic feet per minute. It probably recycles the air in this entire room in a couple of minutes. 40,000 pounds. 4 elephants. 1 GPU. If I can get up on here, this is actual size. I wonder if this can play Crisis. Only gamers know that joke. So this is our brand new Grace Hopper AI supercomputer. It is 1 giant GPU, utterly incredible. We're building it now. Every component is in production, and we're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access, and they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us.
Ay, Google Cloud y Microsoft serán los primeros en utilizar esto.
If you would like to have an AI supercomputer,
Qué barbaridad.
of course, come and install it in your company. We also share the blueprints of this supercomputer with all of
Vamos a
Running
adelantarlo
on
un
the
poco.
NVIDIA Grace Hopper Superchip can enable 3D video conferencing on any device without specialized software or hardware. Starting with a standard 2D
Bueno,
camera
aquí
sensor
están
that's in
comentando
most
lo de la
cell phones,
construcción, ¿no?
laptops, and webcams, and tapping into the processing power
来发明新的交流方式。NVIDIA は生成系 AI を
Oh, en diferentes idiomas.
コミュニケーション技術に革命をもたらします。
NVIDIA Maxine 3D
Videoconferencias
together
3D
with Grace
inmersivas.
Hopper. Bring immersive 3D
Madre
video
mía.
conferencing to anyone with a mobile device, revolutionizing the way we connect, communicate, and collaborate.
为什么他说我不会讲国语？我要讲单位。Okay, so all of the words coming out of my mouth, of course, was generated by AI. So instead of compression, stream, and decompression, in the future, communications will be perceive, stream, and reconstruction. regeneration. And it can be generated in all kinds of different ways. It can be generated in 3D. Of course, it can regenerate your language in another language. So we now have a universal translator. This computing technology could be, of course, placed into every single cloud. But the thing that's really amazing, Grace Hopper is so fast, it can even run the 5G stack. A state-of-the-art 5G stack could just run in software in Grace Hopper, completely free. Completely free. All of a sudden, a 5G radio runs in software, just like a video codec used to run in software. Now you can run a 5G stack in software. Of course, the layer 1 PHY layer, the layer 2 MAC layer, and the 5G core, all of that computation is quite intensive, and it has to be timing precise, which is the reason why we have a BlueField 3 in the computer, so that kind of precision timing networking. But the entire stack can now run in a Grace Hopper. Basically, what's happening here, this computer that you're seeing here, allows us to bring generative AI into every single data center in the world today. Because we have software-defined 5G, then the telecommunication network can also become a computing platform like the cloud data centers. Every single data center in the future could be intelligent. Every data center could be software-defined, whether it's internet-based, networking-based, or 5G communications-based. Everything will be software. EDA, SDA, which we just mentioned, generative AI for enterprise, and of course the edge. Each one of these applications have different configurations of servers.
Buah, qué barbaridad.
Different
Lo de...
focus of applications, different deployment methods, and so security is different, operating system is different, how it's managed is different, where the computers are will be different. And so each one of these diverse application spaces will have to be re-engineered with a new type of computer. Well, this is just an enormous number of configurations. And so today we're announcing, in partnership with so many companies here in Taiwan, the NVIDIA MGX. It's an open modular server design specification, and it's designed for accelerated computing. Most of the servers today are designed for general purpose computing. The mechanical, thermal, and electrical is insufficient for Grace Omniverse server. Grace, same.
Vale, ahora está ya tocando el tema del Omniverse. Que, bueno, el Omniverse es lo que ya estuvieron hablando también en otra presentación, que es como un conjunto de aplicaciones por nube, por red, que se ejecuta en esto, en lo de los centros de datos que llaman ellos ahora, que básicamente manejan inteligencia artificial y pues va todo a una. Es todo en un mismo sitio. Todo se hace ahí. Es brutal. Vamos a pasarlo un poco. NVLink más Infinity Band, están diciendo. Vale. Que recordemos el NVLink en las gráficas de ordenadores sobre mesa, de jugar a videojuegos, las tarjetas gráficas de PC, lo han suprimido porque ya nadie hace slide. Slide es poner dos gráficas o más conectadas entre sí para jugar a videojuegos. Ya no se hace, no vale la pena. Vale la pena cambiarte la gráfica y solo utilizar una porque hay juegos en que sí que va bien, hay juegos que no se nota mejora de rendimiento, entonces vale la pena cambiarte la GPU y ya está. Porque no está bien se abandonó, no está bien optimizado, perdón. Pues bueno, esto yo creo que lo podíamos ya omitir un poco. Hemos visto lo más importante. Esto del Omniverse ya son aplicaciones de diferente tipo que se utilizan mediante la nube, ¿vale? Pero en 3D, ¿vale? Entornos 3D y es una puta barbaridad. ¿Ves? Con robots y todo, o sea... Mira, Ubuntu también está por ahí. Canonical Ubuntu. Oracle Cloud. Microsoft Azure, que es lo de la nube de Microsoft. Vale, a ver esto. ¿Ves? Tú le escribes Y escribiendo te lo hace. Te hace lo que quieres hacer en lo que estés realizando, ¿no? Es una puta pasada. Es una barbaridad. A ver. En los últimos 25 años vengo a Taiwán, me vendes cosas, a ver, a ver.
Omniverse will be the first thing I'm going to sell you. And this
Será lo primero que te venderé.
because this will help you
Porque te ayudará a revolucionar tu negocio y convertirlo
and turn it into a digital business and
en
automate
un
it
negocio
with AI.
digital y automatizarlo con IA. Construirás productos en digital primero antes de hacerlo. Claro.
Before you make it physical. You will build factories and plan it in digital first before you make it in physical. And so, in the future,
O sea, primero se planificarán las cosas en digital y luego se llevarán a cabo en físico. Por lo tanto, en el futuro Omniverse es un gran problema. Ahora les mostraré muy rápidamente Omniverse en la nube.
And so we put the whole thing into a cloud managed service, and it's hosted in Azure. This particular experience you're going to have, the computer is in California. And Sean, I'm sorry I took so much time, so you're going to have to.
We'll go quick.
Split.
So
Okay.
this is, let's take a look at the Omniverse Cloud. So this is, just a web browser, and we're looking now into Omniverse Factory Explorer. It's running 10,000 kilometers away in our Santa Clara headquarters, and we're leveraging the power of our data center now to visualize this factory floor. We're using real factory data from Siemens and Autodesk Revit to take a look. It's a cloud application, so we can have multiple users collaborating. Let's go ahead and bring up Eloise's screen, and we can see that we have these two users in this environment. And Jeff on the left there is going to look at some markup. We have this task to perform. We need to move this object. So we can have Eloise just go ahead and grab that conveyor belt, move it over, and as he does so, you'll see that it's reflected accurately and completely in real time on Jeff's screen. So we're able to collaborate with multiple users, and even in bringing up this demo, we had users from around the globe working on the process. East and West Coast, United States, Germany, even Sydney, and of course here in Taipei, to put this together. Now, if we're modifying our production line, of course, one of the things we want to do is add the necessary safety equipment. So we're able to simply drag and drop items into Omniverse and modify this production environment and begin tweaking this and optimizing for performance even before we break ground with construction.
There was Jin. That could be a character. That could be one of the users of Omniverse interacting with you, answering questions, helping you with him in Omniverse. Tools from so many different other partners, Adobe Firefly, for example, Getty, Shutterstock, and it integrates into this entire environment. And it makes it possible for them to generate
tools by organizations such as Getty Images and Adobe.
Vamos a pasarlo un poco rápido, si no.
Data using NVIDIA Picasso.
Va de esto, tú le escribes lo que quieres hacer y te lo reproduce, te lo hace.
Technologies allows WPP to build accurate photorealistic visual content and e-commerce experiences that bring new levels of realism and scale to the industry.
Qué barbaridad. WPP.
And then we're going to use Metropolis, our AI deployment, edge
¿Y ahora esto qué es?
to deploy the AI. Okay?
Replicar.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, Planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA Metropolis enables Pegatron to quickly develop and deploy cloud-native, highly accurate AOI workflows across their production lines. Omniverse Replicator generates synthetic datasets of PCBA defects, which are too complex and costly to capture in the real world, like scratches and missing or misaligned components. Pegatron then combines the synthetic data with NVIDIA pre-trained models, NVIDIA Tau for training, adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
Did you see that? The whole factory is an Omniverse. It's completely digital. Imagine if you have digital
Una fábrica
information in your
digital.
hands, what can you do with it? Almost everything. And so this is one of the things that's really exciting. What you just saw is basically
Buah, ¿cómo va a cambiar esto todo, eh? Esto es una barbaridad. Vale, vamos a adelantarlo a ver si vamos al final.
Nova Orin, which is a reference system, a blue
Migrating away from
and that entire stack has been built, and let's take a look at it.
A ver,
To
¿qué es
improve
esto?
productivity and increase worker safety, factories and warehouses are migrating away from manual forklifts and guided vehicles to full autonomy. NVIDIA Isaac AMR provides an integrated end-to-end solution to deploy fully autonomous mobile robots. The core of the
Robots
solution
móviles,
is
totalmente
Nova
autónomos.
Orin, a sensor suite and computing hardware that enables mapping, autonomy, and simulation. Nova's
Buah, esto es lo primero que yo creo que más se van a interesar. Yo creo que esto es en lo primero en lo que más se van a interesar para hacer muchos trabajos. Porque esto va automático y ya no es por tenerlo ahí automático, a lo mejor va más rápido, falla menos y tal. Es porque esto te puede ayudar mucho. Te puede ayudar mucho. Una persona a lo mejor no puede hacer X cosa, pues un robot sí que lo podría hacer. En ese sentido estaría bien. Bien visto, claro.
With these maps in place, on-robot LiDAR or cost-effective cameras provide autonomous navigation that works reliably in the most complex and dynamic environments. Isaac Mission Control optimizes route planning using the cuOpt library. To improve operations, developers can use Isaac Sim and NVIDIA Omniverse to create realistic digital twins of the operating environment. This allows fully autonomous robots to be trained on complex tasks entirely in simulation. All operations can be fully validated using Isaac Sim before deployment to the real world. Isaac AMR accelerates your migration to full autonomy, reducing costs and speeding deployment of the next generation of AMRs.
Navigate, trillions of dollars will be invested.
Vale, vamos a pasar al último.
And if you have to...
O sea, esto es de todo lo que han hablado hasta ahora, ¿vale? Aceleración por computadora, generación de inteligencia artificial, el Grace Hopper, el NVIDIA en toda la nube, ¿no? Implementación por todos lados de la nube. O sea, en internet, ¿no? Se encuentra en internet todo. El Spectrum X MX, el MGX, el Nova Orin, bueno, todo esto. Luego aquí abajo está la super gráfica esta que han hecho, ¿vale? El super proceso de datos, se podría decirle. Centro de datos, centro de datos que han hecho. El más potente del mundo seguramente sea, o de los más. Seguramente el más potente. Y por mucho. HGX H100. A ver cómo se despide.
And there are so many different configurations of servers in a enterprise grade, enterprise secure way in every single cloud. And lastly, we would like to extend AI to the world's heavy industries, the largest industries in the world. So far, our industry, we do that by automating. Thank all of you for your part. We do that by automating factories. Thank all of you for your partnership.
Creo que ahora ya se va a despedir. Ha sido bastante larga, 2 horas. Casi 2 horas. Ahí está la canción. La canción de... Y se ha acabado cantando. Cantando, tú. Pues nada. Ya lo tenemos. Vamos a quitar esto. Y vamos a darle al Zelda, que yo creo que ya es hora, ¿eh? Hemos estado prácticamente casi 2 horas, viéndolo. Ha estado interesante. A mí por lo menos... de muchas cosas no controlo, ¿vale? Sí que es verdad que no controlo demasiado. Pero de otras sí que ya las había visto. De otras presentaciones ya habían dejado ver algo. Y bueno... Pero vamos allá, vamos con el Zelda, vamos a ver si continuamos por donde lo dejamos. Y... A ver, sí, teníamos que ir a... Bueno, quería ir a la meseta, a la zona inicial del juego.